Good afternoon, students. How are you all? Please switch on your video audio so that we can talk. Yes. Hello all. Harshil, Mihir. Switch on video. We are first time meeting for this course. Yes. Harshil, Mihir, Zenith, Amalraj, Kushal, everyone. Switch on your video. Yes. Mihir, Zenith. Okay, let me switch on my video first. Hello all. Yes, are you all with me or not?
Yes, sir.
Yes, sir.
So switch on video so that we can have proper interaction first. Introduction. This is for all the students. Okay. Are you all with me or not?
Yes, sir.
You can video. Can you switch it on? Yes. Hello. Kushal, Kamalraj. મિલન ઉમંગ એક વખત વિડીયો ચાલુ કરો તો આપણે ઇન્ટરેક્શન થાય કે શરૂઆત કરીએ. ઝાકી યસ એક સ્ટુડન્ટ કર્યો. મિલન ઝાકી
Hello, sir.
ગુડ આફ્ટરનૂન. કેમ છો બધા?
Fine, sir.
આપણે 6 મહિના પછી મળીએ છીએ.
How are you doing, sir?
I'm good. How are you all?
Yes, fine.
Yes, Kamal Raj. Okay. So first of all, જ્યારે પણ આપણે લેક્ચર માટે બેસીએ, કારણ કે તમે ઘરેથી અટેન્ડ કરો છો, તો પ્રોપર એવું એટમોસ્ફિયર ક્રિએટ કરવાનો ટ્રાય કરજો કે તમને બીજું કોઈ ડિસ્ટર્બન્સ ના થાય અને આપણે આખું લેક્ચર સારી રીતે સેશન કરી શકીએ. રાઈટ? ઓકે. So I hope all of you are with me. Just write your attendance one time in a chat box so that I get to know that you are actually with me. કારણ કે ખાલી 2 સ્ટુડન્ટે વિડીયો ચાલુ કર્યો છે. Yes, now you can switch off your video. Okay, this is not your final attendance. I will again take your attendance one time. This is just to get you know that how many are actually present. Okay. So you see, our course is computer organization architecture. Let me show you the syllabus first. Syllabus is available on university website, so we can use that also. Okay. So is the syllabus visible to you all? Students?
Yes, sir.
Yes, sir.
So the subject code is 3140707, and for this course we are going to learn that what are the different architectural component of any microprocessor or a microcontroller. So we have to learn the architectural point of view. Now all of you are computer engineer or IT engineer. Whenever you want to design any particular software, your software has to map efficiently with the drivers, right? And you might be learning a course for driver writing also. Now when you write the driver has to be as per the architecture of the microprocessor. In market there are thousands of different microprocessors, microcontrollers available. Now a driver for a particular microprocessor or a particular microcontroller, that has to be written as per all the architectural components that are present in that particular microprocessor or microcontroller. So what are those components? If you learn about the hardware which is running your software, then you will be able to better design the drivers as well as the softwares which are running on those drivers. And that is why this course is offered to you, that what are the different architectural components of a microprocessor or a microcontroller, right? The Intel Core i3, Intel Core i5, these are all advanced microprocessors. Microcontroller, if we see, then 89C51, and there are so many different advanced microcontrollers. Now, when we want to learn about architectural component, we need not go for advanced microprocessor, directly jump into an advanced microprocessor. Rather than that, we first like to learn about what are the architecture. For that, one of the most famous microprocessor that we are going to learn, that is Intel's 8085. Intel's 8085 microprocessor. And so in the university syllabus also, they have given that we will learn this 8085, Intel's 8085 microprocessors architecture. So the syllabus is again available on the website. And yes, now this is the lab session. So we will discuss theory in the theory session. Let us first see, for the lab session, our experiment number 1. Is this visible to you all? Experiment number 1.
Yes, sir.
Okay. So our experiment 1 is to learn about working of 8085 simulators using, there is one simulator available which is open source, GNU Sim 8085, and basic architecture of 8085 microprocessor. So what are the objectives? After you successfully complete, now this is a learning experiment. After you successfully complete this experiment, you should be able to learn how GNU Sim 8085 is working. And you should get familiar with basic 8085 microprocessor architecture. So for that, what we require equipment, we require a desktop computer with installation of GNU SIM 8085. Now all those students who has laptop or desktop available with them, they can use this simulator which is open source. And for other students who do not have this simulator available with them because of the constraints, so we are trying to find out whether any good, already I know there are many simulators available for mobile phones also, but which one is most suitable to you, that we will let you know. So yes, but for laboratory purpose, as per the university syllabus, we have to learn about GNU 8085. So this simulator is for Intel 8085 microprocessor. It contains, what it contains? It contains assembler and debugger for the Intel 8085 microprocessor, which is available for Linux also as well as Windows also. Now all the students, you have already learned about different components. Can any of you tell me what is the use of assembler? Why do we need assembler? અસેમ્બલરનું કામ શું છે? અસેમ્બલરની જરૂર કેમ પડે આપણને?
ટ્રાન્સલેટ કરવા માટે.
શેને ટ્રાન્સલેટ કરવા માટે?
આપણે જે કોડ આપી આપણે ઇમ્પ્લિમેન્ટ કરવું એમ.
Okay. Do you know what is the difference between compiler and assembler? Students, compiler વચ્ચે અને assembler વચ્ચે ડિફરન્સ શું છે? તમે આગળ સી લેંગ્વેજ ભણ્યા હશો, એના સિવાય બીજી પણ લેંગ્વેજીસ ભણ્યા હશો ને, તેમાં તમે યુઝ કર્યું હશે આ કમ્પાઇલર. તો કમ્પાઇલરનો યુઝ કેમ થાય? Students?
Sir,
Yes.
so both of them converts the code like from assembly language to machine language. But one does line by line and another does the whole code at same time.
Okay. See, compiler basically it is used to convert higher level language into the machine level language. So now the advanced compilers what are available in the market, they have assemblers already with it. In earlier days, there were separate assemblers and separate compilers. So that compiler task was to convert a higher level language program, right? You are writing either in C language or Java language. That program you are writing in a higher level language that has to be converted into assembly. And then assembler converts it to machine language code. Ultimately, the machine is made of transistors, right? Whether microprocessor, there is ALU or a control circuit, everything is made of transistors. Yes or no? Are you all with me on that? Any microprocessor or a microcontroller, that is ultimately made of transistors. Are you all with me for that or not?
Yes, sir.
Okay. So whether we want to store some data into memory or whether we want to transfer data from one memory location to another memory location, or whether we want to apply some operations such as addition, subtraction, multiplication, logical operations like ANDing operation, ORing operations. These all operations we want to do on the content of the transistors only. So the transistor, how it works? it works on electrical signals. So the electrical signal can be either 0 volt or 5 volt, and how we apply this signal onto basic electronics, right? Onto a transistor. Here, typical microprocessors, they are made for, you have heard the name CMOS?
Yes, sir.
Yeah. What does mean? CMOS means complementary MOSFET. That means there is an N channel MOSFET used and P channel MOSFET used. These both MOSFETs are used to construct that particular integrated circuit. Integrated circuit. That means the whole circuit made of the transistors and its interconnections along with the necessary capacitors and resistors, that whole circuit is fabricated on a single silicon wafer. So we have miniaturized the whole circuit. That is integrated circuit. So that particular microprocessor IC will be having billions of transistors on it. Now, to switch on or switch off a particular transistor, we need to apply a signal on the gate. There are three terminals of a MOSFET, right? There is a gate terminal, there is a drain terminal, and there is a source terminal. If you remember, we have learned the construction of a MOSFET. Now, depending on what signal we apply on the gate of the MOSFET, the gate will be switch on or switch off.
Okay.
Then, using such multiple transistors, we can apply some operations, right? If we want to switch on a transistor, then using a switch, when we connect these switches into certain combination, we can make logic gates, like logic AND gate, logic OR gate. You have learned the subject of digital electronics, right? Using the switches only, switches are made of transistors. Then we make gates. Using gates, what we make? We make different combinational and sequential circuits. Combinational circuits like multiplexer, encoder, decoder. These all circuits you have learned in the course of digital electronics. Sequential circuits, like the basic element is what? Flip-flop. Flip-flop is able to store 1 bit of memory. Such 8 flip-flops connected together makes one 8-bit of register. And such we can make different registers, counters, timer circuits. These are all sequential circuits. Combining these all makes one microprocessor. So how your course started? In the semester 2, you learned about basic electronics. Then in semester 3, you learned about digital electronics. Now, once you have learned digital electronics, using those circuits, we are learning how to make a microprocessor. Right? But when we program on a computer, there are some things, like first is our operating system. Operating system has, many operating systems has drivers inbuilt with it. So the drivers are the software which are written, which deals with the hardware, whether any adder circuit or any subtractor circuit or any multiplier circuit or a signal which is transferring, or a control circuit which is transferring a signal from one memory location to another memory location. These all different things are handled by the driver, right? And so many times in our computer, if we have some new hardware component attached and its driver is not already installed, we need to install the hardware, install that particular driver, right? So coming back to the topic of compiler, right? Compiler, nowadays compilers are available which do not convert to assembly but directly convert higher level language into machine level language. When we say machine level language, what is that machine level language? Move data from one register to another register. Okay, for that certain signals or certain instructions which are properly available for that particular microprocessor, that is our machine level language. Move content from one memory location to another memory location, add the content of accumulator and one particular register, that is addition. Such all different machine level tasks, they are handled by machine level codes. Any company, whether it is Intel or AMD, who are making microprocessors, nowadays they are not just making microprocessors available with them, they are also giving the drivers also, so that we don't have to worry about, so that the computer engineers and the IT engineers do not have to worry about what is happening inside the machine. You are writing in C language or Java language, right? Even if you don't know how many transistors are inside the microprocessor, okay, and what instruction is actually being executed in one particular transistor inside our microprocessor. Why this is possible? This is possible because of now we are able to have operating systems and the softwares which gives us user interface, so that user can easily do different tasks. They can do programming also, or even if some non-engineer is using the computer, they do not have to know what is working inside the computer. They just have to use the computer. And so the compiler converts higher level language to machine level language, and the assembler converts assembly language codes into machine level language. Okay. There are still many microprocessors, microcontrollers available in the market. Whenever a new microprocessor or new microcontroller is launched into the market, whether Texas Instruments or Intel, or Atmel, any such company is releasing a new processor or a new controller in the market, along with that they give its data sheet and how to use that particular processor or controller. So what they give, they provide different assembly level instructions using which coding can be done on that particular processor or controller. Right? Not necessarily all microprocessors or microcontrollers have to be programmed in the C language or Java language. Many such processors and controllers which are present in our day-to-day life, right? Like some processor might be available in the refrigerator or a microwave oven or a washing machine or a dishwasher. They are dedicated for a certain task. They need not to be programmed via higher level language. Using assembly level language, this programming is done. Okay. Any questions so far? Are you with me?
Yes, sir.
Okay. Any other students? Are you with me?
Yes, sir.
Yes, sir.
Any questions? Feel free to ask. Okay. Then what is the task of debugger? Students, what is the task of debugger? Whether assembly language program or a higher level language program. A new engineer who is not known what are the different assembly level language. They do not know the syntax of the language. They do not know how to work on it. So what debugger does? Debugger is a tool that helps you to test whatever program that you have written, that is correct or not, or will it be suitable to run on a particular microprocessor or a microcontroller. Okay. So yes, coming back to this, can you see the Word file?
Yes, sir.
Yes, sir.
You just copy this link, https://gnusim8085.github.io. From this, you can download the GNU Sim software. This is a simulator. Okay, I am writing this into the chat box. Okay, so this is the link where you can download the simulator. Now this simulator is specifically designed for Intel 8085 microprocessors. There are so many different microprocessors. This is specifically designed for 8085. This 8085 is an 8-bit microprocessor. What do we mean by 8-bit microprocessor? Is that the arithmetic and logic unit that is present on the microprocessor is able to do operations such as arithmetic or logical operations on 8-bit data at a time. We want to add two different binary numbers. So maximum 8-bit long binary numbers can be added or subtracted or compared, ANDing, ORing, different such functions can be done on maximum 8-bit of data at a time in one machine cycle. The arithmetic and logic unit is able to do operations on 8-bit data. Then there are some advanced processors and controllers also, which can handle 16-bit operations at a time. Then there are 32-bit microprocessor, 64-bit microprocessors, right? So when it says that the microprocessor is 64-bit, suppose you might have purchased your laptop or mobile which has a 64-bit microprocessor. What it means that whatever is the arithmetic and logic unit is available in it, in one machine cycle that is able to perform operation on 64-bit data in one machine cycle. Now, can you tell me what is the time of one machine cycle? Suppose you have one microprocessor whose speed is, let us say, for example, we take 2 gigahertz. તમારી પાસે એક એવું માઇક્રોપ્રોસેસર છે તમારા લેપટોપમાં કે મોબાઈલમાં જેની સ્પીડ છે 2 ગીગાહર્ટ્ઝની. એનો મીનિંગ શું થાય કે એની એક ક્લોક સાયકલ કેટલા ટાઈમની હશે? Students, if the processor speed is 2 gigahertz, what is the time of one clock cycle? Anyone? It is easy. जो फ्रीक्वेंसी 2 गीगाहर्ट्ज होय तो टाइम पीरियड કેટલો થાય?
Sir, 1/2 gigahertz, that is.
હા, તો એ કેટલું થયું? 1 divided by 2 into 10 raised to 9. That means 1/2 into 10 raised to -9. 0.5 nanosecond. Yes, एक machine cycle, एक clock cycle 0.5 nanosecond ની થઈ. તો એ પર્ટિક્યુલર માઇક્રોપ્રોસેસર 0.5 નેનોસેકન્ડની અંદર એક ઓપરેશન કરી શકશે, એક મશીન ઓપરેશન કરી શકશે. તો એક સેકન્ડમાં કેટલા કરશે? 2 into 10⁹ એવા ડિફરન્ટ ઓપરેશન એક સેકન્ડમાં કરી શકે. અબજો એડિશન, સબસ્ટ્રેક્શન એવા ઓપરેશન્સ એક જ સેકન્ડની અંદર થઈ શકે. એક ઓપરેશન કરતા 0.5 nanosecond લાગી. So that is the speed of microprocessor. Okay. Can you see the word file?
Yes, sir.
Okay. So this is the snapshot of that GNU simulator, which we are going to use for our course. આગળના બધા લેબોરેટરી એક્સપેરિમેન્ટ આપણે આની અંદર કરવાના છે. Now for that, what you have to do, your task is to summarize the article which I am sharing with you, the link, how to use this GNU simulator. તમારે સ્ટડી કરવાની છે કે આ GNU simulator નો યુઝ કેવી રીતે કરીશું. I have shared the link in the chat box. So that જ્યારે આપણે એક્સપેરિમેન્ટ 2, 3 આગળના એક્સપેરિમેન્ટ પરફોર્મ કરીએ ત્યારે તમને સિમ્યુલેટર યુઝ કરતા આવડવું જોઈએ. ઓકે, તો આ તમારે સ્ટડી કરવાનો છે. આ આપણા એક્સપેરિમેન્ટ 1 નો ઓબ્જેક્ટિવ નંબર 1 છે, to learn the working with GNU Sim 8085. Then second objective is that to get familiar with basic 8085 architecture. Okay, so before I show you, I request all of you, because you are already connected on internet, kindly find out 8085 architecture and tell me what are the different components of it. This is for all the students. Yes, anyone? Students? Zenith, Mihir, Umang, Astha, Diksha? મિલન, 8085 નું આર્કિટેક્ચર શોધો તો એમાં કયા કયા કમ્પોનન્ટ તમને દેખાય છે? See, this is the first session. I am just introducing you. Okay, આપણે આ બધું આગળ ડિટેલમાં ભણવાના છે. Okay, let me show you. This is the architecture for 8085. Can you see this?
Yes, sir.
હવે જો એમાં કયા કયા components છે, which are the different components that you observe? The heart of a microprocessor, that is arithmetic and logic unit. Arithmetic and logic unit is connected with one component which is called as accumulator. Accumulator is one register only, but this register is directly connected with arithmetic and logic unit. So many operations will be done on this accumulator register only, whether addition or subtraction. At that time, one of the component will be one of the data. That particular byte will be stored in the accumulator, and second might be stored in the temporary register, on which the arithmetic and logic unit will perform operation such as addition, subtraction, ANDing, ORing, arithmetic logic operations. Okay. Now, whatever operation is done by it, by arithmetic and logic unit, it's associated with it, there is a flag register. Flag register. Suppose we are doing one addition operation. We are adding 1 byte. FFH plus FFH. તમે એડિશન કરેલું છે ડિજિટલમાં? FF હેક્સમાં હેક્સાડેસિમલમાં લખેલું છે પ્લસ FFH. હવે તો નંબર તમને ખ્યાલ આવે? F લખ્યું છે એટલે શું થયું? બાઇનરી 1111. FF લખ્યું એટલે 8 વખત 1. So this is hexadecimal representation. Achha. When we add these two numbers, what will be the result of addition? आठ वक्त 1 बाइनरी में બંનેનું એડિશન કરીએ તો શું આવે? 1 + 1 0, carry 1, 111. 1 + 1 + 1, 1 carry 1, 1 carry 1, 1 carry 1. આવું ક્યાં સુધી આવશે? 8 વખત આવશે. અને લાસ્ટમાં એક કેરી જનરેટ થશે. આ નંબરને કેવી રીતે લખાય? 1FEH. Are you all with me, or is it too tough? FFH અને FFH નું એડિશન કરીએ તો એડિશનનો આન્સર શું આવે? 1FEH આવે. ટોટલ કેટલા બીટ થયા? 17 બીટ થયા.
Yes, sir.
તો એ કેસમાં રિઝલ્ટ છે, રિઝલ્ટ તે અક્યુમ્યુલેટરમાં પાછું સ્ટોર થશે. શું સ્ટોર થશે? FEH. અને 1 જે કેરી રહી એ ફ્લેગ રજિસ્ટરમાં એક કેરી માટેનો ફ્લેગ રજિસ્ટર હશે. એક કેરી ફ્લેગ રજિસ્ટર 1 થઈ જશે. ધેટ મીન્સ કે જે પણ ઓપરેશન હાલમાં એડિશન ઓપરેશન કરેલું છે તે ઓપરેશન કરવાથી એક કેરી જનરેટ થયેલી છે. And such, there are many flags. This flag register has many flag bits. Some bit to represent whether carry is present. Some bit to represent that whatever operation is done, that is resulting in overflow. Then some carry flag will represent that whatever operation is done, after that result is 0. So if result is 0, then there will be a null flag. That null flag will be enabled. So why this flag register is there? Architecture માં flag register ની જરૂર શું છે? Because this flag register then can be used to decide further instruction. કોઈ બે નંબરનું એડિશન કરી દઈએ. If we add just two different numbers, and then on that we want to write a conditional instruction that if addition of previous two numbers generates a carry, then move data from one register to another register, right? So when we want to perform such operations, at that time if conditions needs to check the content of the flag register, and based on the condition what we are applying, it will take a decision. Okay. Any questions, students?
No, sir.
Then let us see what are other components in the architecture. This is one component called as a instruction register. Instruction register has the opcode. Opcode is a short form for operational code. Okay. The machine language code can be divided into two parts. We say that assembler or compiler converts the higher language or assembly language into machine language code. Into machine language code, what the controller is understanding, there are two parts. One is called as opcode, and another part is what we call as operand. This space is missing, I'm writing below. Operand. Opcode is the code word which indicates a certain instruction. Instructions like add, subtract, logical ending, logical ORing, then move, jump. These all different instructions that we can give to arithmetic and logic unit. They are instructions. How this ALU will understand? ALU will understand based on this opcode. So like for example, suppose 0 1 0 1 1 1 0 1, this 8-bit which can be written in hex, this is 5CH, right? This particular opcode might mean something for the arithmetic and logic unit, either to perform addition or to perform subtraction, right? How the circuit which is constructed inside the arithmetic and logic unit, remember circuit, that circuit is done connections based on these opcodes. So when you give such opcode to it, then one of the circuit in the arithmetic and logic unit will get enabled, and it will do the task of either addition, subtraction, whatever instruction is given, right? And what is the operand? Operand is the data on which operation has to be performed. For example, we want to perform addition. Addition on what? So addition on data which is available in the accumulator and temporary register, or addition on the data which is available in two different registers which are in the RAM or ROM, right? So those are the operands. Operands are the data on which operation is performed, and opcode is the instruction which indicates which operation has to be done. Okay, so this is a particular instruction which is made of opcode and operand. This is stored inside this instruction register. Okay, one clarification. Which instruction? The instruction which is going to be executed next, that will be stored inside this instruction register. जो इंस्ट्रक्शन नेक्स्ट एग्जीक्यूट होने वाली है वो इंस्ट्रक्शन रजिस्टर में स्टोर रहेगी, and then data from which will be opcode will be fed to arithmetic and logic unit, and it will do the task as per the opcode given on the operands given. Okay, and so associated with it, what we have? Instruction decoder and machine cycle encoding. This will decode what is the instruction given and instruct the ALU what task to be done. So far, I am just simply telling what are the different blocks and what are their tasks. We are going to learn this more in detail, and architecture of 8085 is one of the most important question for university exam also. Okay, any questions, students?
No, sir.
So far we have seen 6 different blocks in the architecture. Then let us see what is this. Okay, first of all, these are the temporary register. Register B, register C, register D, register E, H and L. These registers are such that they can be used individually also, or they can be used in pair also. Suppose we want to store a 8-bit data, then we can use this temporary register, B or C or D or E, H, L, any of them. But suppose we want to store a 16-bit data, then that can be stored in a pair, like BC pair, DE pair, and HL pair. And opcode instructions, they are different instructions are given for each of the register to do different operations like addition, subtraction, moving data, storing data, loading data. These all instructions are available. So they are the temporary register. You can see register A લખ્યું નથી. Register A કયો છે? That is accumulator. That is most closest to the ALU. These all circuits are made, fabricated on a single silicon wafer. જે આપણી માઇક્રોપ્રોસેસરની આઈસી છે તેમાં આ બધાની સર્કિટ હશે. હજુ આપણે ખાલી બ્લોક ડાયાગ્રામ જ જોઈએ છે, રાઈટ? એના અંદર શું હોય એ તમે ડિજિટલ ઇલેક્ટ્રોનિક્સમાં ભણી ચૂક્યા કે એક રજિસ્ટર કેવી રીતે બને, એક એક્યુમ્યુલેટર કેવી રીતે બને, એક એન્કોડર સર્કિટ કેવી રીતે કામ કરે, એક મલ્ટીપ્લેક્સર સર્કિટ છે તેનું કન્સ્ટ્રક્શન શું છે, આ બધું તમે ડિજિટલ ઇલેક્ટ્રોનિક્સમાં ભણ્યા. Okay, then next there is a stack pointer. Stack pointer all of you know, right? Because એ તમને C language ભણાવ્યું છે, એમાં શીખવાડ્યું હશે. What is the use of stack pointer?
Sir, it points to the topmost element of the stack.
Yes, but suppose we are calling a particular macro. At that time, what is the use of stack pointer? એક કરંટ પ્રોગ્રામ રન થાય છે અને એમાં બીજો એક મેક્રો કોલ થાય છે.
Sir, it points to the next instruction.
That is program counter. whatever next instruction in the program is going
Yes,
to
sir.
be executed, that memory location is stored in the program counter. Suppose you are running one program, main program, and on that there is a call for a different macro. Okay, so when that particular macro is called, whatever is this memory location जहां अगर थी करंट प्रोग्राम, जहां से करंट प्रोग्राम होल्ड हुआ है, वो लोकेशन स्टैक पॉइंटर में रहेगा. So that once after executing the macro, where to go, that location is stored inside the stack pointer. एक बार ये मैक्रो रन हो जाए उसके बाद वापस कौन से मेमोरी लोकेशन में कॉल के बाद का नेक्स्ट इंस्ट्रक्शन है वो स्टैक पॉइंटर में से पता चलेगा. Is that clear?
Yes, sir.
Then there is a latch. Yellow color block is given. A latch which is for incrementing address or decrementing address. Increment or decrement a particular address, that is latch. Why this is used? Because most of the times when instructions are written in the program memory, they are mostly written in sequence, so that one instruction is executed from one memory location. एक memory location में से एक instruction execute हो गया, then next instruction we want to execute, for that the address has to be incremented or decremented. So that thing is done by this latch, incrementer and decrementer latch, which is associated with not just address buffer but also with the data address buffer. Okay, then there is 8-bit of internal bus. These are the parallel wire lines which transfers 8-bit data at a time. 8 bit નો ડેટા એક સાથે પેરેલલ માં ટ્રાન્સમિટ કરવા માટેના 8 અલગ-અલગ વાયર કમ્બાઈન કરીએ તો એને એક બસ કહેવાય. Then over here this is interrupt controller, which are associated with different pins. These are all different pins of microprocessor, and different interrupts can be generated for arithmetic and logic unit. हम इंटरप्ट का यूज क्यों करते हैं? कई बार कोई एक प्रोग्राम रन हो रहा है और उससे इंपॉर्टेंट कोई टास्क करना है तो उसकी एक प्रायोरिटी सेट हमें करनी है, तो इंटरप्ट्स का यूज करके हम उसकी प्रायोरिटी सेट कर सकते हैं. सपोज कोई एक प्रोग्राम रन हो रहा है, हमने माइक्रो प्रोसेसर में प्रोग्राम लिखा हुआ है दैट एक वाटर टैंक में से जब पानी पूरा भर जाए, राइट, उसके बाद मोटर को स्विच ऑफ करना है, ऐसा कोई प्रोग्राम है, तो कंटिन्यूअसली वो जो उसका डेटा पिन है उसमें से वाटर का लेवल सेंस करता रहेगा और लेवल पर्टिकुलर वैल्यू रीच करे उसके बाद उसको एक्शन लेना है. अब ये नॉर्मल प्रोग्राम जब रन हो रहा हो उस वक्त यदि सडन पावर फेलियर हो रहा है, राइट, और सडन इलेक्ट्रोमैग्नेटिक इंटरफियरेंस आ रहा है, तो उस वक्त नॉर्मल वर्किंग है उसको स्टॉप करना पड़ेगा. उसके लिए हम इंटरप्ट्स का यूज कर सकते हैं, तो उसके लिए एडिशनल हमको प्रोग्राम लिखना पड़ेगा. सो इंटरप्ट आर हार्डवेयर इंटरप्ट्स आर ऑल्सो देयर एंड सॉफ्टवेयर इंटरप्ट्स आर ऑल्सो देयर. And these interrupt controller is associated with these 6 different hardware interrupts. That means वो माइक्रो प्रोसेसर की पिन के ऊपर हम सिग्नल देंगे तो प्रोसेसर का नॉर्मल वर्किंग इंटरप्ट होगा, और जो पिन के लिए अलग से मैक्रो लिखा होगा वहां पर उसका प्रोग्राम काउंटर डाइवर्ट हो जाएगा. Then there is a serial controller. Serial, this is for serial data input and output. Parallel transfer and serial transfer. What is the difference? This 8-bit bus is a parallel bus. That means on that particular line, on that particular wire, 8 bits data can be transferred. एक मशीन साइकिल जो एक टाइम इंटरवल रहता है उसमें 8 बिट का डेटा पैरेलली ट्रांसमिट हो रहा है. जहां पर सीरियल में क्या हो रहा है, यहां पर सिर्फ एक ही वायर है. There is only one wire. So serial input and serial output. Whatever is the parallel data, 8-bit data is available that we want to transfer serially. So bit by bit, that data is transferred by on this one line. आप में से किसी ने आर्डिनो का यूज किया है? आर्डिनो उनो किसी ने प्रोजेक्ट बनाया हो या ऐसा कुछ? स्टूडेंट्स कोई भी कहीं पर कंपटीशन में पार्ट लिया हो, हैकाथॉन में, ऐसे कोई? Yes, students. Okay, not a problem. तो आर्डिनो जब हम हमारे कंप्यूटर के साथ कनेक्ट करते हैं, वो जो डेटा जो ट्रांसफर हो रहा है वो सीरियली ट्रांसफर होता है. Okay, then there are other components also. There are timing control circuits. Everything we will learn. Now I want to stop here and wait for you to ask some questions. If you have any queries, feel free to ask. Anyone? Okay, then just the instructions what I have given. Okay, Harshil, very good. You have written in the chat box. And Zenith, very good. You have also written the components in the chat box. Milan has given answer 1 FEH. That is correct. There is a question from Milan. Are we going to work on Arduino? No. We are going to work on 8085, Intel 8085. Let me just first take attendance. Okay, Zaki is present. Zaki?
Yes, sir.
Okay, Sachin?
Present, sir.
Sachin?
Yes, sir. Yes, sir.
Chinmay? Chinmay? Chinmay is absent. Dhairya? Dhairya Ruparelia? Dhairya is absent. Milan?
Yes, sir.
Hitesh?
Yes, sir.
Then Hina? Hina? Hina is absent today. Chirag?
Yes, sir.
Vansi?
Yes, sir.
Kamal Raj?
Yes, sir.
Astha?
Present, sir.
Shelby?
Present, sir.
Jai Kishan?
Present, sir.
Hiren?
Yes, sir.
Naresh? Naresh Kimzuria? Naresh is absent. Mohammad Munaf?
Yes, sir.
Yatish?
Yes, sir.
Mohib Hussain? Mohib Hussain? Absent. Krish Kumar? Krish, Krish is absent. Mishi,
Present, sir.
Kushal,
Present, sir.
Umang,
Present, sir.
Parth, Parth Makadia, Parth absent. Karthik, Karthik, Karthik absent. Deep, sorry. Yes, where is the sheet? Okay, just let me start again. Zaki is present.
Yes, sir.
Okay. Then Sachin,
Yes, sir.
Milan. Milan is present. Hitesh. Hitesh is absent. हितेश हमारा तो बोले प्रेजेंट. ओके, चिराग.
Yes, sir.
फैंसी प्रेजेंट. कमल राज.
Present, sir.
कमल राज.
Sir.
आस्था.
Present.
Present, sir.
ओके, सेल्वी.
Present, sir.
ओके, जय किशन प्रेजेंट.
Yes, sir.
हिरेन प्रेजेंट.
Yes, sir.
देन मोहम्मद मुनाफ प्रेजेंट.
Yes, sir.
यतीश.
Yes, sir.
यतीश प्रेजेंट. मिसी.
Yes, sir.
मिसी प्रेजेंट. खुशाल प्रेजेंट.
Present, sir.
उमंग
Present,
प्रेजेंट.
sir.
Yes, sir.
उर्विसा.
Present, sir.
मिहिर.
Yes, sir.
निराली.
Present, sir.
राहुल. राहुल. राहुल शर्मा एब्सेंट. मिलन. 63
Yes, sir.
नंबर मिलन.
Yes, sir.
ઓકે, તો આગળ બીજા કયા મિલન હતા? મિલન ઘડિયા 19 નંબર મિલન. 19 નંબર મિલન પ્રેઝન્ટ છે.
Hello, sir. Yes, present.
19 મિલન એબ્સેન્ટ. ઓકે,
Yes.
દીક્ષા.
Yes.
Present, sir.
ઝેનિત.
Present.
ઓમ. ઓમ દેત્રોજા. હર્ષિલ.
Present, sir.
ઓકે, કોઈની અટેન્ડન્સ બાકી રહી છે? સ્ટુડન્ટ્સ, કોઈની અટેન્ડન્સ બાકી રહી ગઈ છે જેમનું નામ બોલવામાં ના આવ્યું હોય તે? ઓકે ઓકે, યસ. તો જે ટાસ્ક આજે આપ્યું છે મેં લિંક શેર કરેલી છે. તમારે ખાસ તો પહેલાં GNU સિમ કેવી રીતે કામ કરે છે એ તમારે શીખી લેવાનું છે. અને 8085નું આર્કિટેક્ચર ઓવરવ્યૂ જેમાં જે એક્સપ્લેન કર્યો, આપણે નેક્સ્ટ લેબમાંથી એનો યુઝ કરવાનો છે એક્સપેરિમેન્ટ 2 થી. એટલે એનો સ્ટડી કરી દેજો, બરાબર. નાવ once I will get your email addresses, then I will share this doc file with you, or better I will be using one canvas software. So on that I can assign these experiments and all, and you can submit your output in that only. Okay? So